Good morning, everyone. I am Mrs. SWATHI, Assistant Professor, Department of AADS, Primary Engineering College. In this presentation, we will understand what the decision tree is, how the ID3 algorithm works, and how it builds a tree using entropy and information gain. So first, what is decision tree? Decision tree is a supervised machine learning algorithm used for a classification and prediction. It contains root node, internal node, and leaf node. For example, to predict whether the person will buy a product or not, we check the attribute like age, income, and interest. So here the importance of a decision tree is to easily to understand, interpretable model and used in a real world application. So next one, what is ID3? ID3 stands for Iterative Dichotomiser 3. It was developed by the Rose Quinlan in 1986. It is used to build the decision tree using a entropy and information gain. So the attribute with the highest information gain is selected as a root node. So here it is used for building a decision tree by employing the top-down and greedy approach to the given set to each attribute at very tree node. In ID3 algorithm, it is a recursively partitioned into smaller subset as a tree is being built, which is the main factor to construct the decision tree. So next, how to calculate the entropy value. So if all the elements belong to the single class, it is considered as a pure, and if not, is considered as a impurity. If the class distribution is a 0 and 1, it has a high impurity. And if it is 0.5 and 0.5, it is the smallest purity, that is highest impurity node. So the formula for calculating the entropy is entropy of S equal to summation minus P of I by T, that is how many S and how many no, into log 2 P of I by T. So the formula for information gain is entropy of S minus summation of P of S by A into entropy of S by A. So this is the example for a decision tree algorithm. Here the dataset contains 14 attributes. Here we have class label as a play cricket. So the problem statement here is, so using this attribute we have to calculate whether the student can play a cricket or not. So we have 14 attributes. We have to calculate the entropy value first. So first we have to calculate how many S and how many no. Here we have 9S and 5 no. So the formula for calculating the entropy is minus P of S into log 2 of S minus P of no into log 2 of P of no. So the value for S is 9. So minus 9 by 14 into log of 9 by 14 minus 5 by 14 into log of 5 by 14. So the value of entropy is 0.94. So first we have to take the first attribute, that is outlook. Here the categories of outlook are sunny, rain and overcast. So I have to calculate the individual entropy for the three attributes, three categories. So the value is 0.971, 0.971 and 0. So then you have to calculate the average for all the categories in outlook. So the formula for the average entropy is P of sunny into H of outlook equal to sunny. That is P of sunny is 5 by 14. So out of 14 we have 5 sunny into H of outlook equal to sunny. The value is 0.971 plus P of rain. P of rain is 5 by 14. Again in the 14 attributes we have 5 rain into H of outlook equal to rain plus P of overcast into H of overlook equal to overcast. So the average entropy value is 0.693. So here we have calculated the average entropy information. So from that we can calculate the information gain. So because to calculate the information gain, you need a total entropy and average entropy value. So already we have calculated the total entropy value, that is 0.94. So I have to calculate the information gain equal to 0.94 minus 0.693. That is average entropy. So the value of outlook is 0.247. So our second attribute is temperature. The categories of a temperature is hot, mild and cool. So first you have to calculate the entropy for a hot, cool and mild. 1, 0.811, 0.9179. So the average is, the value is 0.9108. So information gain is H of S, that is 0.94 minus I of temperature. That is the average entropy information for a temperature. So the value of temperature is 0.0292. Our third attribute is the humidity. So the categories are high and normal. So first you have to calculate the entropy for high. The value is 0.983 and for a normal 0.591. Average entropy information for a humidity is 0.789. So the information gain for a humidity equal to 0.94 minus 0.787. So the value of a humidity is 0.153. So a last attribute is a wind. The categories for wind is a weak and strong. So the value of weak is 0.811. The value of strong is 1. So the average is 0.892. So the information gain for a wind is 0.94 minus 0.892. The final value is 0.048. So now we have to compare the information gain for all the 4 attributes. So here we have a highest information gain in the outlook attribute. So I want to consider the parent node based on the information gain value. So the outlook will be placed in the parent root node. So the categories of outlook is sunny, overcast and rain. So you have to take a separate table what are all the sunny value has. So we have out of 14 we have 5 sunny values. So I have to take the separate table for sunny. And for a overcast we have all the attributes as the class label as S. So you can conclude it as a S. So now you want to expand sunny and rain. So first you have to calculate for a sunny. So again you have to calculate the total entropy for a sunny new data set. So for a new data set, we have 2S and 3 no. So based on that, the value of entropy is 0.971. And again, the first attribute here is categorical, that is temperature. The categories are hot, mild and cool. So the value of entropy is 0, 0 and 1. Average is 0.4. So the value is 0.571. So for a humidity, the value is 0.971 and for a wind, the value is 0.0202. Here, the humidity has the highest, so it will be chosen as the next node. Here, already we have placed the root node as the outlook. So after that, from the we have close to the overcast by S. So when you are expanding the sunny, the humidity has the highest information gain value. So I have placed the next node as a humidity. So next, you have to calculate the value for rain. So here we have, by calculating the temperature, the value is 0.0202. Second attribute is a wind, 0.971. We can ignore the humidity and outlook because we have already placed the humidity and outlook in a decision tree. So here, wind has the highest information gain. So you can place the wind under the rain. So this is the final decision tree. Here the outlook will be a root node. So under that categories are a sunny, overcast and rain. So humidity has a category like a high and normal. Wind has a category as a weak and strong. So this is the final decision tree in ID3 algorithm. So here the applications of ID3 algorithm is medical field, banking and finance, marketing and business, education and spam reduction. Advantages are simple and easy to understand. Their tree structure is a initiative to interpret the result, and fast and efficient. It uses a greedy approach, so it can be used for a small data set. Automatic feature selection, it selects the best attribute using a information gain. It supports a multi-class classification, so it can handle more than 2 classes. It generates the human readable rules, that is, if the outlook is a sunny and humidity is a high, then the play is a yes or no. Next one, the drawbacks. First one is the overfitting problem. So it produces the deep trees and poor performance on unseen data. Second one is no pruning mechanism. It does not remove the unnecessary branches. And third one, it cannot handle the continuous attribute directly. It requires the discrimination. And it biased towards the attribute with many values because the information gain favors the multi-valued attributes. It's sensitive to the noisy data. The small changes may affect the tree structure. Thank you.